China is moving forward with a plan to establish a long-term outpost on the moon. Right now, the groundwork for the first lunar base is already being laid in a systematic way. It all begins with robots, and we've already seen quite a few Chinese robotic missions operating there. But that's only the opening phase of a much larger strategy, one aimed at eventually placing humans on and even beneath the moon's surface. That said, a long list of challenges stands in the way. The moon is an incredibly hostile place to do just about anything. Even achieving a safe landing remains a serious test. The biggest obstacles come from the moon's extreme environment. First, there is no atmosphere, no air to breathe, and no protective layer to shield the surface from the sun's intense heat. As a result, when sunlight hits the ground, temperatures can soar to scorching levels above 120 degrees Celsius. But when the sun sets, the temperature can plunge below minus 130 degrees Celsius. Because the moon rotates much more slowly than Earth, it experiences about 14 continuous days of daylight followed by 14 straight days of darkness. On top of that, there are other less familiar dangers, such as cosmic radiation, something you must face once you leave Earth's protective shield. Our planet has a magnetic field generated by the movement of molten metal in its core. The moon, however, lacks a global magnetic core. That means all that radiation slams directly into the surface. So if humans want to live there, we'll need an effective barrier between ourselves and the deadly rays coming from the sun. Unfortunately, an ordinary metal wall won't be enough to solve that problem. Then there's the threat of meteorites. When you look at the moon's surface, covered in craters, what do you think caused them? Rocks from space, and this is an ongoing process. The moon is constantly bombarded by debris. Earth is too, but our atmosphere creates enough friction to burn most incoming rocks into dust before they ever reach the ground. Once again, the moon has no such protection. Maintaining life in that environment will be an extremely difficult task. It's true that American astronauts lived on the moon decades ago, but those were only brief visits lasting about 3 days. The goal of the 21st century is long-term habitation, working towards a permanent human presence on the lunar surface, and this is exactly what China has already begun testing. For example, in 2019, the Chang'e 4 lander carried a small sealed biosphere experiment called the Lunar Microecosystem. It was a container filled with seeds such as cotton and potatoes, along with fruit fly eggs and yeast. The idea was to try to sustain life by providing air, water, and nutrients, then observe how these organisms would survive in the moon's low gravity and high radiation environment. At first, it seemed like some of the seeds were doing quite well. A cotton plant actually sprouted, becoming the first green leaves ever to grow on the moon. But even that new life was short-lived. Chinese scientists reported that within just a few days, extreme temperature swings killed everything inside the container. This clearly demonstrated just how unforgiving the lunar environment truly is. And that's why China has invested so much time and effort into using robots there to lay the groundwork for a future human presence. We can think of China's lunar base strategy as a 3-phase plan. Phase 1 is reconnaissance, Phase 2 is construction, and Phase 3 is habitation. Right now, we're roughly in the middle of Phase 1, which is the focus of the Chang'e missions. So what might Phase 2 actually look like? There are a few ways to build a base on the moon. The most obvious solution would be to construct it on Earth, then launching and land it on the lunar surface. Simple in theory, but incredibly difficult, risky, and expensive in practice. Another option is to use local resources found directly on the moon, and this is exactly where China is concentrating its efforts. A future mission called Chang'e 8, scheduled for launch in 2028, will carry an experiment designed to turn lunar soil into building materials.
Here's how the construction process on the moon is expected to unfold. An autonomous robot would collect lunar soil and pack it into containers that serve as casting molds. These containers would then be placed into a high-temperature furnace to form solid shapes, such as rectangular blocks, cubes, or curved arches. Next, another autonomous robot would stack these bricks and apply a binding material at the joints to create low-rise structures. Similar bricks could also be laid across the surface to build infrastructure like roads and landing pads. These thick stone-like blocks would provide excellent protection against hazards such as radiation and meteorite impacts. They would also serve as effective insulation against the moon's extreme temperature swings between day and night. However, there are drawbacks. A brick house isn't naturally suited to withstand internal pressure. Because the moon has no atmosphere, we would need to create a pressurized environment inside any habitat. Rectangular shapes with rigid edges don't have the natural strength required to contain an artificial atmosphere. Think about objects like gas tanks or water towers. They're always round. So inside a brick structure, we would still need a rounded internal design to form a truly livable, pressurized environment. That's the more traditional construction method using lunar soil, but China is also exploring a more futuristic concept, a 3D printed habitat known as the moon pot vessel. This approach eliminates the need to lay bricks manually, but it comes with its own complications. You can't turn raw lunar soil directly into 3D printing material. It first has to be mixed with a binding agent, and that binder would need to be transported from Earth, meaning the method isn't completely self-sufficient. Even so, the moon pot design has unique advantages. Before printing begins, autonomous machines would lay down a thick foundation made from a concrete-like material produced from lunar soil. This provides a stable base and helps absorb vibrations from potential moonquakes, which occur more frequently than many people realize. To create the pot structure, the soil is heated to its melting point, mixed with the binder, and then deposited in circular layers as the print head moves around. The shape is designed to mimic the natural strength of an eggshell and uses 3 layers of material, an outer shell, an inner shell, and a triangular rib structure in between to provide core strength. Because of this design, the habitat could be pressurized without needing any additional internal lining. This multi-layered approach still creates an effective barrier and provides strong thermal insulation. 3D printing would also make it easier to construct taller buildings, which actually makes sense on the moon. Low gravity would allow people to move up and down using ladders with far less effort, and the lack of an atmosphere means wind and weather would never be a concern. These construction plans are ambitious, but they're also grounded in practical thinking, assuming China can solve one major issue: energy. Whether it's firing lunar soil into bricks, running 3D printers, or simply keeping the lights on, a lunar base will require a reliable power source. For that reason, China is looking towards nuclear energy. In 2025, the Chinese and Russian governments announced a new partnership to build a nuclear power plant on the moon. This may sound surprising, but Russia has long wanted to play a key role in China's lunar base plans, even if it wasn't always clear what they could contribute. For example, in 2023, Russia's space agency launched Luna 25 in an attempt to land on the moon and assist with the reconnaissance phase, but the probe lost control and crashed into the surface. They haven't tried again yet. Still, one thing Russia undeniably knows how to do is build nuclear power plants. The state-owned company Rosatom is a global leader in reactor manufacturing and enriched uranium production. It doesn't just build nuclear infrastructure for Russia, it exports reactors to other countries as well. Rosatom has even constructed a floating nuclear power plant in the Arctic, so a nuclear power plant on the moon may not be as far-fetched as it first sounds.
In many ways, the moon could actually be a better place for nuclear energy. Cooling a reactor, for instance, might be as simple as placing it in a location that never receives sunlight. We know the lunar surface becomes extremely cold at night, but the same is true for any permanently shadowed area, such as the interior of a deep crater. That means a power plant could be built there without constant concerns about overheating. Then there's the issue of nuclear waste, a serious challenge on Earth. But since the moon is already saturated with cosmic radiation, it's difficult to make that environment significantly worse. If the first surface construction projects go as planned, China has ambitions for an even larger and more advanced lunar settlement, going underground. Scientists know that China is very interested in exploring lunar lava tubes. These are Vaishal underground tunnel networks formed by ancient volcanic activity. We know they exist because we've observed locations where the roof of a lava tube has collapsed, leaving an opening that reveals a hollow cavern below. These caves provide natural protection from meteorites and radiation. They're also insulated from the extreme temperature swings on the surface. In other words, they could be close to the ideal place to build a base. Naturally, China already has plans to investigate this as part of its robotic exploration phase. The Chang'e 7 mission, scheduled for launch in 2026, will carry ground-penetrating radar to map the subsurface near the lunar South Pole and search for potential underground caverns. So now we understand the current robotic reconnaissance phase and some of the future construction concepts. But how do we move from here to there? China's lunar base is expected to begin construction in the 2030s. The target site is the South Pole, an area believed to hold the greatest concentration of usable local resources. At first, the facility will be entirely robotic, with no human involvement in the building process. Robots will handle all the heavy work, and once everything is operating safely, that's when human crews will arrive. China has scheduled 5 major lunar landings between 2031 and 2035, each delivering a different component of the future base. The first mission will establish a command center with basic power and telecommunication systems. The second will bring research and exploration facilities. The third will focus on in situ resource utilization technologies. The fourth will apply those systems in a robotic exploration and experimentation mission, complete with sample collection and return. Finally, the fifth landing will set up astronomical observatories and Earth observation capabilities from the Moon. This timeline points towards Chinese astronauts living on the Moon by the end of the next decade. China will likely attempt to land its first astronauts there within this decade to demonstrate its capabilities to the world, but it doesn't appear interested in repeating short-term visits like the old Apollo strategy. Of course, China isn't the only nation aiming for a permanent lunar base. The United States has major plans of its own as well. Thank you for watching all the way to the end of the video. If you enjoyed it and found it interesting, please support us with a like and subscribe to the channel so we can keep bringing you more engaging and fascinating content. We truly appreciate your support.